Each side of a square is increasing at a rate of 6 centimeter per second. At what rate is the area of the square increasing when the area of the square is 16 centimeter squared? Okay, and let's see here. We need to find out the formula of a square. Okay, a square is a rectangle with the same length, right? So let's name this side here as x, and this side is also x. So this is a square, and we need to find out the area of a square. Area of a square. And the area of a square, of course, it is the width times the height, right? So we will have the area is equal to x times x. But this x is squared, right? So we will have x times x that will equal to x squared. Okay, but here is the catch. Because the rate here is increasing, right? The rectangle is increasing, so this a is depend on time, and this x is also depends on time. Or we can rewrite this as this. So at is equal to xt squared. So imagine this function. Always imagine this function, but for short, I can always use this one, right? But if I talk about a is equal to x squared, imagine that both of them are a function of time. Good. And now, because we need to find out the rate of the increase of the area, we need to take the differentiation between a with respect to t. Okay, so we will have dA over dt. However, we have only x variable here, so we can only differentiate a with respect to x. But to get this, we need to multiply this by dx over dt, right? Good. Okay, now here we can calculate this. So dA over dx here is the derivative of this function. So we will have dA over dt is equal to 2x, and then this one will be dx over dt. Okay, now let's see here what is the question asking us. At what rate is the area of the square increasing when the area of the square is 16 centimeter squared? Okay, so that is the key. When the area is 16 centimeter squared, right? We know from this that x is the square root of a, or the square root of 16. That will be 4, right? But we are asked to find out what is the rate of the area here, dA over dt, when this a is equal to 16. Okay, now we need to plug in the numerical values. So we will have 2x, so we will have 2. But when a is 16, x is 4. So we can just plug 4 here. And then dx over dt. So what is dx over dt? It is the rate of the increasing side, right? So we are given by the problem. So this one here, 6 centimeter per second, is dx over dt. Okay, assuming that it is constant, we can just plug that in. So I will have 6 here. And 2 multiplied by 4, that will be 8. But we still need to multiply it again by 6. Now 8 times 6, that will be 48. And we need to find out the unit here. The unit of the area here is centimeter squared, right? Because the x is in centimeter and this x also in centimeter. So I have 48 centimeter squared. And dt is the time. And the time here, the unit of the time is second. So I will have second here. And I think that's all for this problem. The answer is 48 centimeter squared over second. Good. And I think that's all for this problem. Thank you for watching. And if you get any questions, send me your problem to this email here, rdsatria11@gmail.com. Okay? And thank you for watching once again. See you in the next video. Bye-bye.